Solve 2y plus 5 root y equals 12. First, to get everything in standard form, we need to move that constant to the left-hand side. So we're going to subtract 12 on both sides of the equation. This gives us 2y plus 5 root y minus 12 equals 0. And now we have something that we can use a substitution to convert into a quadratic equation. So we're going to want this to be in the form 2 times something squared plus 5 times something minus 12 equals 0. And then we need to figure out what to put inside the parentheses so that the new equation is equivalent to the original one. So we need to take something and square it and end up with y. What can we square to end up with y? Well, the answer is the square root of y. And if we put the square root of y inside the other set of parentheses, we end up having those terms match as well. So the substitution we need to make is we need to let z equal the square root of y. When we make that substitution, this equation becomes 2z squared plus 5z minus 12 equals 0. And we can try to solve this quadratic equation by factoring using the AC method. In this case, AC is negative 24 and B is 5. So we need two numbers that have a product of 24 and a sum of 5. Those numbers are going to be 8 and negative 3. So we use those to split the middle term. This becomes 2z squared plus 8z minus 3z minus 12 equals 0. And we can finish by grouping. The first group has 2z as the GCF, giving us leftovers z plus 4. Both of the terms in the second group have a negative 3 that can be pulled out, also leaving us with z plus 4. And so on the left, the two groups had a z plus 4 in common, and then the leftovers are 2z minus 3. So we have z plus 4 times 2z minus 3 equals 0. Now we can apply the zero factor property and set each of those factors equal to 0. Z plus 4 equals 0, or 2z minus 3 equals 0. And we can solve each of these equations. If we subtract 4, that gives us z equals negative 4. And in the other equation, we can add 3 to both sides, giving us 2z equals 3. And to get z alone, we divide by 2. So that gives us z equals 3 halves. I'm going to write these solutions up on the right-hand side just so that we have more room to work with. Z equals negative 4, or z equals 3 halves. Now, our original equation had y's in it, but we've solved for z, so we can't stop here. We need to use the substitution to write everything back in terms of y. So wherever we have a z, we have to replace that with the square root of y. So here we have the square root of y equals negative 4, or the square root of y equals 3 halves. Now if we look at this first equation, the square root of y equals negative 4, there is no solution to this equation. It is not possible to take the principal square root of something and end up with negative 4. This is impossible. It's not going to give us any solutions, and so we can throw that whole equation away. We have the square root of y equals 3 halves. We know that if we want to solve this for y, we can get rid of that square root by squaring both sides. On the left-hand side, when we take the square root of y squared, we end up with y. And on the right, when we take 3 halves and square it, 3 halves times 3 halves is 9/4. So in this situation, we only have one solution, and that solution is y equals 9/4.